Hi everyone, welcome back to the channel. I'm Manisha. So in this video we are going to see convolutional neural network. The first part of the video will be on the explanation of the convolutional neural network method, and the last part of this section of the video will be on the practical implementation of the convolutional neural network. So what is convolutional neural network? Very quickly, CNN is a class of deep neural networks that are particularly used for analyzing images, and it is developed to automatically learn spatial features from low level details to high level patterns. Let me walk you through this diagram to understand the sequential stages from feature input to classification output. So the first one is a feature inputs, which means the data such as images, text or sound is input into the neural network, and these inputs are raw, which means that it has not yet been processed or analyzed. The next is a feature extraction, which is general purpose phase. At this stage, the data pass through one or more types of neural networks that are adept at extracting relevant features, and these networks may include convolutional neural network, then recurrent neural network, LSTM long short term memory, then attention pooling layers. After processing these layers, the network has a set of good features for classification, and these are the features that are most informative for making decision or classification. Next stage is a fully connected layer or dense layer. So at this stage is where the decision happens. So the good extracted features from the previous layer are now passed through the one or more fully connected or dense layer, and these layers are called as a fully connected layer because each neuron receives input from all neurons in the previous layer, and which allows the network to learn non-linear combination of high level features, and that's why it's called as a fully connected or dense layer. And this phase is a specific application based phase. You can call it as a classification based phase. The next is the predicted class. So finally the output of last fully connected layer is used to make a classification decision. So here I provided some important research paper for those who like to read research paper. I used couple of diagrams from these papers. CNN transformed raw image data into a form that is easier for computer to process without losing important information. So it is not just used we can say for recognizing object, but it's also understanding and classifying them at a much deeper level. So let's break down the structure of convolutional neural network into layers. So first layer, in here you see input layer, convolutional layer, the next is a pooling layer, flattening layer, fully connected layer, and output layer. So in total we are going to see 6 layers in convolutional neural network. Each layer is designed to process and transform the data progressively, extracting features. Then some layers are responsible for reducing dimensionality, and finally classifying the input into the categories, which happens in the output layer, but we are going to see them one by one in detail. Next, in this diagram we see the architecture of the convolutional neural network. I just want to show you that there are two main classification that we can do in CNN architecture. First is a feature learning. Some layers that I mentioned that comes under feature learning, and the fully connected layer and output layer comes under classification. So this is a we can say general purpose, and this is the specific application based phase of the CNN architecture. So let's see the very first layer of the convolutional neural network, which is an input layer. This is the layer where it receives raw image data such as digits and pre-processes it using convolutional filter to extract key features which are essential for the classification tasks. So in this figure, this is handwritten digits, this is MNIST data set. It's just to show you what we can see in input layer. After input layer, we will see the convolutional layer. So let's break this is very important layer of the convolutional neural network. So let's break it into the 5 important parts. First one is filter, then it is also called as a kernel. Also, some people call it as a feature detector. The next one is feature map, then stride, and then there is a padding, and then the last one, the fifth one, is activation function. So these components are important to learn as we know them for practical, as we need them to know for practical implementation. So you can also see the code. To implement convolutional layer in convolutional neural network, we are going to use conv 2D, 32 filters, and the filter size is 3 by 3, stride size is 2 by 2, padding is zero padding, activation function is ReLU, input shape is 28 by 28, and you can give any name to the convolutional layers. So let's start with a filter. So in here I try to introduce the concept of filter. You can see the filter of 2 by 2 size, and the feature input is of 5 by 5 size. So a filter is a small matrix applied over input data to extract the specific features through convolution operation. So let's see the mathematics behind how filter works. In here I try to show you the convolution operation, which is fundamental component of convolutional neural network, using this simple example. So here 3 by 3 is a kernel size and input size is 5 by 5 are used to produce the feature map of 3 by 3 size. Convolution involves the sliding the kernel over image, aligns it with each possible 3 by 3 block of image, multiplying corresponding elements and summing the results. This is the overall explanation about the kernel, the interaction between image input and the kernel. So I'll try to explain it using this example. In here, the kernel is a line on the top left corner of the image, which is this one highlighted here. The second is element wise multiplication between kernel and the part of image it covers. So multiplication is like 1 into 1, and then summing these products. I have showed this operation, mathematical operation, in here, and this is how we can calculate the element at position of 0. So feature map size is 3 by 3 here, and this process repeats for each position. So now the filter is moved towards right, where stride size is equal to 1. We can see what is stride in a bit. So filter now it's in the new position, and the same operations that I explained before is going to happen here. So it performs element wise multiplication between kernel and this part of image. Afterwards it will perform the summation of these product values, and so the calculation here is this the final value we got is 14, is the second cell in the feature map. The position of this cell is 0, 1. Similarly, the kernel moves one cell towards right and it performs the calculations like before, and the value at feature map at position 0, 2 is 11. This way it captures the important spatial features necessary for the further layers in convolutional neural network to classify the image. Finally, to conclude the concept of the kernel, this is a process of convolution in a CNN using 3 by 3 kernel on 5 by 5 input matrix to produce 3 by 3 feature matrix. And the formula, this is the formula to compute the size of the feature map. So the formula is Fm is equal to I minus k plus 1, which indicates how to calculate the dimensions of the feature map, where I is a dimension of input, k is a dimension of kernel size, and plus 1. These operations captures important features from input data such as age or a texture, which are important for the subsequent layers to perform the recognition, image recognition. In here I just want to show you the feature map, the final feature map, which is this one. After calculating the all values at each stage during the model development, the size of feature maps are important to know. For instance, after convolution, the size of feature map is different than the after pooling layer operations, and therefore it's good to know the size of feature map. Now we will see the concept of stride in convolutional layer. The stride is a step size at which a convolutional filter moves across the input data. So in this animation you can see that it is moving towards the right and then horizontally and vertically, and the stride determines the how filter translates over the input matrix. Also it impacts on the size of the output feature map, also the degree of overlap between region processed by the filter, and how it impacts on the size of feature map we can see in a bit. So in here we will see the impact of stride of a 2 in convolution operation within a CNN. A 3x3 kernel is applied to the 5x5 input image, moving 2 steps at a time. So stride is equal to 2. So both horizontally and vertically, and which results into smaller feature map which is 2x2. Before it was 3x3. As we define stride is equal to 3, the feature map size get reduced to the 2x2. The convolution at top left corner is this one of the image, calculates the value by multiplying corresponding elements of the kernel and the image section, which is highlighted here, and then summing these elements to produce the final feature value, which is 8. Okay, and this process actually reduces the dimensionality of the output, and it allows the network to focus on a important, or I can say higher level features, while also reduces the computational complexity. And this is the formula, this is the computations that happen while calculating the element of feature map. Next, the kernel position is moved by 2 columns on the input image, as we said stride is equal to 2 here. And after performing similar operations like I mentioned before, the next component of the feature map is 11. So this is the computation that we did, and the final value is 11 here at position 0, 1. Here a stride of 2 is used with a 3x3 kernel on 5x5 input matrix, and it is leading to a reduced 2x2 feature map. And the formula used to calculate the feature map dimension is here. So here I is equal to input size, input image size, k is a kernel size, and s is a size of stride, and that's how we can calculate the feature map size. And here goes the final feature map after performing a stride of 2 operation, and that is all about the stride. Okay, so this is the final feature map after performing all the operations. Now we can discuss the next concept, or next component of convolutional layer, which is padding. You can see here an additional border of the pixel are added around the input image to preserve its spatial dimension and prevent the loss of edges here, or you can say border or corner information during convolution. And there are different types of padding, which includes zero padding, which fills the border with a zero. So these borders, dotted borders, will be filled by 0, and no padding where no extra pixel are added. Let's talk about the mathematics behind padding. In here 0 padding is added, so you can see the 0 is at border pixels of the image input, and 3x3 kernel to slide with a stride of 2 while preserving the input dimension, so it results in a 3x3 feature maps. The formula to compute the dimension of feature map is this one. It calculates the feature map size, where I is input size, k is a kernel size, then p is a padding size, and the s is a stride size. Next component of convolution layer is activation function. What is activation function? It helps the network to learn complex pattern relationships within data, and usually or commonly ReLU, which is a rectified linear unit, is used to introduce non-linearity into the network. Talking about a specific place of activation function or specifically ReLU in convolutional layer and how it works, this is the example that I would like to show you. This is the input image 5 by 5 kernel and feature map. So this you already have idea about these three things, but after getting a feature map, ReLU function is applied which sets all negative values to the 0, and you can see the final feature map is transformed here. So why we apply activation function in convolutional layer, or we can say convolutional neural network? Because it enhances the network ability to learn non-linear features by introducing non-linearity into the model. Next, here I just wanted to show you the list of the activation function you can use as per the problem that you are going to handle. So you can see the sigmoid tanh, hard tanh, ReLU, leaky ReLU, parametric ReLU, ELU, swish, then soft plus, then threaded ReLU. These are the activation functions, but commonly used activation function in convolutional layer is a ReLU. So to sum up the convolution layer of a convolutional neural network, I use this figure from a research paper. So first, the figure shows the sequence of operation in a CNN. Starting with a multiple input feature maps, the network applies convolutional filters, each producing new feature maps, which is here, that shows the specific features in the inputs, and these features maps are then processed through an activation function, typically as I mentioned ReLU, to introduce non-linearity, and followed by the pooling layer, which we are going to see in a bit, that reduces the dimensions from, for example, here 4 by 4 to 2 by 2 using pooling layer of size 2 by 2. The resulting feature map are serialized, or we can say flattened, into a vector form before being fed into a fully connected layer, where the final classification decision is processed based on the learned features. So this is how the convolutional layer works. The next layer of the convolutional neural network is a pooling layer. So let's talk about the function and the importance of a pooling layer in a CNN. So the pooling layer is used to downsample feature maps by reducing their spatial dimension to enhance computational efficiency, but it is without losing the important information. And there are two types of pooling that we can use. That one is max pooling and the another one is average pooling. Max pooling takes the maximum value from each window, or you can say kernel, of the feature map, while average pooling takes the average value from each window of the feature map. Please note here the input for the pooling layer operation is a feature map which is coming from the convolutional layer. So pooling layer actually decreases the amount of data pass it to the subsequent layer, and this layer, it's an optional layer, still it is important because it improves the network performance by focusing on really important features. So here I provided the function that we are going to use to implement pooling layer in the our program, that is max pooling 2D of size 2 by 2. Let's see the mathematics behind pooling. So here we have 5 by 5 feature map, and we will use a 2 by 2 window with a stride of 2 to reduce the dimensionality. So the first is max pooling, which takes the maximum value from each feature map. So in here the max of 1 comma 1 comma 0 comma 3 is equal to 3. So the max element of this window is 3, and so max pooling extract the highest value from each window, and which gets the new feature map where each element represent the maximum value which found in corresponding window of the original feature map. About average pooling, calculates the average value within each window. So here the average of 1 plus 1 plus 0 plus 3 divided by number of elements of this window is equal to 1.25. So that's how we calculate the value using average pooling. Next component of convolutional neural network is a flattening layer. So this layer is typically used to convert two-dimensional or multidimensional output, for instance a pooled feature map from the preceding convolutional and pooling layers into a one-dimensional vectors. Pooled feature map we have, and after pooled feature map we get a flattening layer, and that's the role of flattening layer. So this transformation is important because it allows the data to process by fully connected layer, so which are standard components in neural network for classification or regression task. And to implement a flattening layer we are going to use flatten function. Next layer is a fully connected neural network or a fully connected layer. You can call it as artificial neural network or a dense layer. This layer connects every neuron from the previous layer, input layer, to every neuron in the fully connected layer. So this connection pattern allows the network to learn complex features or patterns from the input data for a task like image recognition or natural language processing, etc. And the function that we used to implement fully connected layer is a dense in bracket 128 is the size of the neural network, and the activation function you can pass like ReLU or softmax. This activation function, as I mentioned before, helps to introduce nonlinearity into the model, which allows it to learn more complex patterns. Next layer and the last layer of convolutional neural network is output layer. This layer is responsible for generating the final prediction, or we can say classification, based on the features learned from previous layers of the network. You can see it here, the final output layer, and to implement the output layer we are going to use dense function, which has 10 units or 10 neurons, and the activation function is equal to softmax. So softmax activation function is used because it outputs the probability distribution over 10 classes, okay, and it ensures that the output values are between 0 to 1. As we already know the all layer of CNN, here I want to summarize it using this example. In this figure, the architecture and processing flow of convolutional layer is used for classifying handwritten numbers or digits from the MNIST dataset. This CNN involves the steps or layers that we already explored. Okay, so the first layer is input layer. So the original image of the handwritten number, it's of a 228 by 28 pixel. The next is a convolutional layers. These layers apply various filters to input image to create a feature maps, and that captures specific aspect of image such as edges, curve, borders, etc. And then next is a pooling layer, which is used to reduce the spatial size of feature maps because of reduction of number of parameters. It helps to improve the computational performance of neural network. The next layer is a flattening layer. The output of the final pooling layer, this one, is flattened into one-dimensional vector, and which is going to feed into the fully connected neural network. So fully connected neural network is a sequence of dense layers that processes the features extracted from the convolutions and pooling layer to determine the or to classify the class of the input image. So for example from 0 to 9 digits. Another important methods that are really important to know while developing a CNN model or any other model, I would say. We will see these methods very quickly. In this figure we see 4 components: forward propagation, then loss calculations, backward propagation, and weight updates. So in forward propagation, the data moves from input to output layer, going through the transformation at each layer based on the current weights. Okay, and once the output is obtained, its difference from the true level is calculated using loss function, which quantifies the prediction error. And in backpropagation, this is a really key phase where the gradient of the loss is calculated backwards through the network from the output to input layer to determine how much weight contributed to the to the error. And the last important part is weight update. So it uses optimization algorithm like stochastic gradient descent, SGD, or ADAM. The weights are adjusted to minimize the loss. So it's just to show you that forward propagation, loss function, backward propagation, and weight updates are important in convolutional neural network. So in loss function, mainly cross entropy and mean squared errors, these are the methods used in CNN. So cross entropy loss used for classification, which means like to predict the correct class probability, while mean squared error loss is used for regression tasks. And this is the line of code that we need to pass. So to compile the CNN model, optimizer we can pass ADAM or stochastic gradient descent. Then loss you can pass a categorical cross entropy, and metrics would be accuracy. So CNN model here specifies the ADAM as optimization algorithm. It uses categorical and cross entropy for the loss function to measure how well the model performs on multi-class classification task, and accuracy metrics as a performance metrics during training of the CNN model. The next is optimizer. Optimizer, we can see the different types of optimizer. I already mentioned SGD, momentum, ADAGRAD, then RMS, prob, then ADAM, and these are the state of memory, then parameters and strength and weakness. These figures, this table I have taken from a research paper. But the here point is that we have to pass the optimizer, and in here we are passing ADAM, but you can pass the other optimizer or other available optimizer as well according to your case study. The next important parameter or concept in CNN is a parameter and hyperparameters. So for convolutional layer, we can set a different hyperparameter, which is kernel size, number of kernels, stride, padding, size, activation function. Then next is a pooling layer. So in pooling layer you can pass a pooling method, which is max or average pooling. Then filter size, stride, and padding also you can pass in pooling layer. The next is fully connected layer, in which you can pass a number of weights or activation function. Then in others, you like a model architecture optimizer we saw, we can also pass a learning rate, loss function, mini batch size, epochs, regularization, weight initialization, and data set splitting. Here I just wanted to give you an idea about hyperparameters that you can set while training your convolutional neural network. Next, here I want to show you this diagram. It's a comprehensive diagram which is summarizing the key components of the convolutional neural networks. So in here, the convolutional layer, you can see pooling layer. There are different pooling layer, activation functions, loss functions, regularization, optimization methods, fast processing, and applications. This is the overall summary or the methods where you can see the convolutional neural networks. And yes, examples, I can just highlight few examples. Convolutional neural network can be used for the image recognition and classification. It also used for the natural language processing for video analysis. Next part is a practical implementation of CNN. I will just go through the code that I already developed in a Colab, and I will just explain how we can implement a convolutional neural network. It's a very basic example. So let's move to the Colab notebook. So the first thing that we are going to do is to install the TensorFlow library. As you can see, I have already installed the library. Okay, before we go further, this notebook is available on my GitHub account. You can download it from there. It's very simple implementation of convolutional neural network. The second step in the implementation is to import the library. As you know, here I'm using MNIST dataset, which includes handwriting images, handwritten digit images, Next is we are going to implement convolutional 2D using this function max pooling layer to implement pooling layer, then flatten function to implement flatten layer, and the dense layer which is fully connected layer. And these are the few other libraries to plot the image. Okay, next is I'm loading the mnis dataset using this code. So mnis.load underscore data function is used, and this after loading it is automatically this code will automatically split that data set into xtrain, ytrain, which is used to train this convolutional neural network. Xtest, ytest is to test the convolutional neural network model. Next step is pre-processing the data set. So here is just reshaping the images. In here I provided few things. So before we build the convolutional neural network, these are the few things that are important to think. So first is the input features, matrix dimensions. So in here the size of each image is 28 by 28 matrix, and the first convolutional layer contains a filter size which is 3 by 3. We saw that in the previous section. Then feature map size after the convolutional layer will be 14 by 14, which means that after pooling layer the size of the features map will get reduced, because we are implementing pooling layer as well, which is optional, but for the demo purpose I am including pooling layer also. Then stride size I am applying 2 by 2. Then padding I am applying 0 padding. Then activation function we are going to use for convolutional layer is ReLU. For pooling layer we are going to use max pooling. Then size of the pooling layer is 2 by 2. Feature map, after applying max pooling layer we are getting the 7 by 7 size of feature map. So you can see here the feature map size is 14 by 40, but after pooling it gets reduced 7 by 7, which means that it is extracting the important features, and it is in a way it is reducing the computational complexity. The next layer is a flattening layer which flattens the 2D feature maps to 1D vector, which this 1D vector is going to pass to the fully connected neural network, which is dense layer, which will have 128 neurons, and we will use ReLU activation function. And the final layer, that is dense layer. In the dense layer we will have 10 units or 10 classes, and we are going to apply softmax function. If you remember from the explanation, I mentioned that there are 6 important layers. The first one is the input layer, second is convolutional layer, pooling layer, then fourth one is a flattening layer, then fifth one is a fully connected neural network layer, and then the last layer is a dense output layer. Now whatever I specifies here we are going to implement. So we are creating CNN model with the different strides, of course. So this is the function con2d, 32 number of kernels we are using. Of kernel size is 3 by 3, stride size is 2 by 2, padding is 0 padding, activation function is equal to ReLU, and input image size is a 28 by 28, and I have given the name to the convolutional layer, which is con layer. I'm also implementing max pooling 2D. You can also use the average pooling 2D. Flattening layer, afterwards the flattening layer is going to implement, and then dense layer, which is fully connected neural network layer, which has a ReLU activation function, and the final layer, which is a dense layer, which has a 10 units or classes, and we applied the activation function as a softmax. So after running this we get this summary. Whatever I mentioned here, you can see it here. The next is compiling the model. So for compilation, this also I mentioned previously, that optimizer is atom. You can use a stochastic gradient descent or momentum or any other according to your case study. Loss function is a categorical cross entropy, and matrix is equal to accuracy. Next is training the model. To train the model we will use a fit function. We are passing for training underscore train data, y underscore train data. Epochs, because it's just for the quick demo, I'm just setting as a 1, but you can set more than 1. Batch size 128. Validation split, so the training set is the 90% data is used for training and 10% data is going to use to validate the trained model. The next part is evaluating the model. So we are using test loss and test accuracy. Next part is evaluating the model. So test loss and test accuracy we are going to generate using CNN dot evaluate function. So we are passing X test and Y test data set to generate to evaluate the model. And finally we have this accuracy, so you can see 95% accuracy. These are the other few details that you can check it later, but this is how the convolutional neural network work basically. So that's all for this video. Thanks for watching the video. I hope you like this video. Please subscribe to the channel if you like this video, and if you have any question, comment, please leave them in comment. The notebook of this video will be available in the description box. The next video in the deep learning playlist will be on recurrent neural network, so stay tuned for that. And thanks for watching the video, and see you in the next video.